So in this lecture, we'll look at the difference between passing an argument to a C function by value or by reference. In the end of the lecture, we wanted to be able to understand the difference between passing by a parameter by value or passing it by reference. And we want to understand from a 229 point of view instead of 201 point of view. So we want to know exactly what is the difference in the number of assembly instructions that are executed when I use one of those two options to pass a parameter to a function. We'll study this question by looking at a simple C program. It's the program is the car C program, and this program has a structure, a complex data structure that has 7 fields. The first field is an integer that's the vehicle ID. Then there are 2 strings, the make and the model of the car, 2 integers, that's the year and the mileage of the car, and then there is a double, that is the cost, and then there is a pointer to the next car structure, which is an address. I declare 2 functions. One is readCar, and notice that readCar takes as an argument a pointer to a car, and printCar takes as argument the value of a car. My main function will create a local variable, myCar, that is of the type of the structure car node, and will invoke readCar by passing the address of this object, and then we'll invoke printCar to print the car, passing the value of this object. So I have to pass the address of my car to the readCar, because readCar will be reading each one of the fields, the value of each one of the fields, and has to write into the object that I created here locally in main. So let's take a look at the code that I have for this structure in C, for this program in C. readCar is a function. The function takes as a parameter a pointer to a car, so car node star car. And now all readCar will do, this is a very simple readCar function, it will fill up all the values of the fields of this car with constants. And the one thing that you have to note is that in readCar, I'm accessing each one of the fields of my structure using the arrow operator, because the car argument that I received is a pointer to a car. So when I'm accessing a structure by reference, I use the arrow operator in C. And then here I have the code for printCar. printCar will print each one of the values of the fields of the car using the proper formatting. And here I receive the value of a car, not a pointer to a car. So here I have the object itself. When I have the object itself in C and I need to access one of the fields of the object, I use the dot operator. So let's take a look at what the, move here a bit. Let's take a look and see what is the format of this object that I have in memory, this car object. And what I have is that the first field of this object is an integer, so 32 bits is the vehicle ID. Then I have 2 strings, each one with 20 bytes. So they go next in memory. Next I have 2 integers, each one is 4 bytes. And next I have a double. A double is 8 bytes. And you'll notice that when I lay my double in memory here, I'll put it at the address 56 instead of the address 52, because double is an 8-byte type, and I must align all doubles by multiples in address that are multiples of 8. So this is a common thing that happens when storing a data structure in memory, is that you may have some areas where you put no data so that you can have the proper alignment. And finally, you have next, that is the address of the next structure, which is an address, so it's 4 bytes, 32 bits. So now what I want to do is to take a look at the assembly code that's generated for the C code. The first thing to notice is that I'm reserving 168 bytes in memory, and just so that we pay attention a bit, notice that my car occupy 68 bytes in memory. So the first thing that we need to consider is why I'm using so much space in memory in the stack for my function, and the reason for that will become clear pretty soon when we generate the code for print car. So then I save in the value of the return address into the stack because I will call those functions read car and print car. And here I'm showing how I generate code for the C code, and I put in comments to indicate each line of the source C code that I generate code for. And of course, the declaration of my car has no assembly instruction, so I don't have any code for a declaration. And then I have the invocation of the read car function with the address of my car. So all I have to do for this invocation is to put the address of the first byte of the my car data structure into a 0. So I'm assuming in this case that the local my car that I allocate here is allocated to start at the address SP88, SP plus 88, and I pass that address to read car. And read car will then read the values into the fields. And then the next thing that I need to do in main is to invoke print car. And here is where the main point of this lecture comes in. To invoke print car, what I need to do is first I will take the value as SP88. Remember, that's the address of the first byte of the my car structure that is local to main. And next I'm making a copy of the stack pointer, which is the lowest byte of the stack that belongs to the frame of main into T2. And I writing T0 plus 72, which is the end of that my car structure. Remember that there were I went up to 68 in my address, so 72 will be the next position. So that will be the sentinel that I'm going to use to stop copying when I'm making the copy of this car. And now I have a loop, and what this loop is doing is loading the word from using the pointer to 0, and storing the word using the pointer to 2, and adding 4 in each iteration of the loop. So I copying one word at a time, and I using T4 as a temporary. So I copying from memory into T4 and storing from T4 into the address given by T2, and increment the pointer by 4 every time. And actually I need to increment both pointers because I need to increment the pointer where I'm copying from and the pointer where I'm storing to. And then I have a test to know whether I have got to my sentinel to the end of the car structure. So notice that this is a loop that we're going to have to loop through and make copies of every word of the car. And then in the end, I'm going to write 0 into a 0 and return from main after recovering the value of array, restoring the value of array into the proper register. So what I need to do now is to take a look at what's happening. This will be a simulation of this code, and the reason I'm doing the simulation is just to illustrate to you all the assembly instructions that have to be executed in order for me to pass this object or this structure by value. So unfortunately in this version of the slides, the red arrows are a little bit off, but let me walk you through what's going on in this code. So what's going on in this code is that I have the initialization of T0 and T2 and the initialization of T3. And what happens now is that at each iteration of the loop, I'll be copying a word from the pointer, the location pointed by T0, and I'll put that word into T4, and then I will write that word into the position point by T2, And next I'm going to increment both T0 and T2, and I'll keep copying. Again, the red arrow is misplaced in the code, so don't pay too much attention to the red arrow, please. And so I will be copying one word at a time until in the end of the loop, I would have copied the entire car. So now I have 2 copies of the car in my stack. The reason why I need a second copy of the car is that I cannot pass the original car according to the source code of my C program. My C program says, when it says, it does a call such as the one in line 27 that says print car and pass my car instead of the address of my car. What C is telling the assembly is that you need to go and you need to make a copy of the entire object in the stack, and you need to pass this copy to the print. And this is exactly what we did, and we did the simulation just so that you can see the number of copies that need to be made. So the program car.c passes the data structure car node to the print car function by value, not by reference. That is why I have so many copies. So a copy of each byte of car node must be made in the stack for each call of the function print car. Instead, we could have passed the address of the copy of car node that was already in the stack. Now, the decision of whether you can pass an address to a function is up to the programmer. In certain cases, it's perfectly all right to do that. In other cases, it's not. So the programmer has to decide. The point of this lecture is that when making this decision, the programmer needs to be very aware of the cost of passing by value instead of passing by reference. So here's the code now that I'm passing my car by reference to print car. So one of the things that changed is that now when I declare print car, I declare print car to receive a pointer to a car, not to receive a car itself. So here is my invocation of print car now, and notice that my print car now, I passing the address of my car instead of passing my car itself. The print car function will change because now it's receiving a pointer to a car, and now the access to each one of the fields in print car also uses the arrow operator instead of using the dot operator that I used before. But now in terms of the assembly, what happened in my assembly is that first of all, I'm going to use a smaller portion of the stack. I only have 112 bytes now. The invocation of read car does not change, it's the same that I had before, but the invocation of print car becomes these 2 lines. Remember that before I had a loop that was looping through and copying every byte of car into another place in the stack. That is not necessary anymore. And this is the end of the program. So in this lecture, what we did was to understand the difference between passing an argument by reference or by value, and we did a simulation looking at the code generate for a simple function, the print car in this case, showing that when I pass a data structure by value, I need to make a full copy of the data structure in C.